The ocean is running a fever, and unlike a human fever that breaks after a few days, this one has been climbing for 9 consecutive years without stopping. Scientists just confirmed that 2025 set a new all-time record for ocean heat content. Not the highest in a decade. Not the highest since satellites began measuring. The highest in all of recorded human history. And the data coming in for 2026 suggests that the ocean is not cooling down. It is holding that record heat, and in some regions, pushing higher still. This is not a future warning. This is a present tense emergency. And the reason most people have not fully grasped how serious it is comes down to a number that most of us never think about. 90%. More than 90% of all the excess heat trapped by greenhouse gases over the past half-century has not warmed the air you breathe. It has warmed the ocean. The atmosphere gets the headlines. The ocean absorbs the damage. And right now the ocean is absorbing more damage faster than at any point in the modern scientific record. To understand why this matters so deeply, you have to understand what the ocean actually does for the planet. It is not just a body of water. It is the Earth's primary temperature regulator. It absorbs solar energy across more than 70% of the planet's surface. It stores that energy in its depths for decades, sometimes centuries. It distributes heat from the tropics toward the poles through vast current systems that drive weather patterns across every continent. When the ocean is in balance, those systems are predictable, stable, and life-sustaining. When the ocean overheats, everything downstream of it changes. And right now, everything is changing at once. The numbers from the scientific record are staggering in their consistency. According to data compiled by NOAA, the upper 2,000 meters of the global ocean gained heat at a rate of between 0.66 and 0.74 watts per square meter, averaged across the entire surface of the Earth between 1993 and 2024. That might sound abstract, but translate it into physical reality and the picture becomes much clearer. The ocean is absorbing the equivalent of several Hiroshima-scale atomic bombs worth of heat energy every single second. Not every year, every second. That energy does not disappear. It is stored in the water, warming it degree by fraction of a degree, pushing temperatures toward thresholds that drive outcomes the planet has not seen in hundreds of thousands of years. Carbon Brief's analysis of the 2025 climate data confirms the full scope of what happened last year. 2025 was in the top 3 warmest years on record for global average surface temperatures, reaching approximately 1.44 degrees Celsius above pre-industrial levels. It set a new record for ocean heat content. It registered one of the largest single year-over-year increases in ocean heat in the instrumental record. Arctic sea ice saw its lowest winter peak ever recorded. Cumulative ice loss from the world's glaciers and from the Greenland ice sheet reached a new record high, and concentrations of carbon dioxide, methane, and nitrous oxide in the atmosphere all reached record levels simultaneously. Every single one of those records feeds into the next year's conditions. The heat stored in the ocean in 2025 does not reset in January 2026. It carries forward. The Climate Adaptation Center confirmed in February 2026 that ocean heat content is expected to remain extremely high for the current year and will likely set yet another record or stay near the 2025 peak. Scientists at the center noted that because ocean heat content changes slowly, the extra heat already stored in the upper ocean would keep temperatures elevated in 2026, regardless of any short-term weather patterns, including even a La Niña cooling phase in the Pacific. The ocean is now so warm that natural cooling cycles can no longer bring it back to where it was just 5 years ago. This is the concept that climate scientists call committed warming. It refers to the additional temperature rise that is already locked into the climate system by the heat currently sitting in the ocean, regardless of what humans do with emissions from this moment forward. Even if every power station on Earth went offline tonight, the ocean would continue warming the planet for decades as it slowly releases its stored heat into the atmosphere above it. The committed warming already baked into the system is estimated to add at least another fraction of a degree Celsius to global temperatures over the coming decades. In a world where fractions of a degree determine whether coral reefs survive or bleach, whether glaciers retreat or collapse, whether monsoon systems stay predictable or become erratic, fractions of a degree are not a rounding error. They are the difference between manageable and catastrophic. The regional consequences of record ocean temperatures are already playing out in ways that are directly affecting hundreds of millions of people. The Indian Ocean is running persistently above its long-term average. A detailed analysis published in April 2026 documented how the warming Arabian Sea is fundamentally altering monsoon circulation across South Asia. The traditional land-sea temperature contrast that drives the monsoon, the difference between the hot Indian subcontinent in summer and the cooler ocean around it, is weakening as the ocean surface warms. The result is a monsoon system that is becoming less predictable, producing intensely concentrated downpours in some areas while leaving others in prolonged drought. Populations of Western India and Pakistan that depend on reliable seasonal rainfall for their food supply and freshwater management are facing a climate system that increasingly refuses to behave the way that centuries of experience have taught them to expect. Coral reefs are bearing some of the most visible damage from ocean warming. The Great Barrier Reef has experienced repeated mass bleaching events in recent years as sea surface temperatures cross the threshold above which coral expels the symbiotic algae living in its tissues. Without those algae, the coral turns white and eventually dies. The Lakshadweep Islands and the Maldives have recorded bleaching events driven directly by the warming Arabian Sea. And these are not just ecological losses. Coral reefs support roughly 25% of all marine species despite covering less than 1% of the ocean floor. They provide food security and coastal protection for more than 500 million people worldwide. Their collapse is not a biodiversity statistic. It is a food and shelter crisis for an enormous share of the global population. Marine heat waves are becoming more frequent, more intense, and longer lasting. A marine heat wave is defined as a period when ocean temperatures in a specific region exceed the 95th percentile of historical conditions for that area for at least 5 consecutive days. In the past decade, the duration, intensity, and geographic extent of marine heat waves have all increased substantially. These events kill fish, destroy seagrass beds, collapse kelp forests, and disrupt the entire food chain that supports commercial fisheries. For coastal communities whose economic survival depends on those fisheries, the intensification of marine heat waves is not an environmental concern. It is an economic collapse happening in slow motion. The feedback loops that ocean warming creates are perhaps the most alarming dimension of the situation. As the ocean warms, it becomes less efficient at absorbing carbon dioxide from the atmosphere. Colder water dissolves gases more efficiently than warm water. A warmer ocean releases more carbon dioxide back into the air rather than locking it in the deep sea as colder, denser water sinks during thermohaline circulation. This creates a cycle where warming makes the ocean less capable of buffering further warming. The system becomes self-reinforcing in a direction that benefits nothing alive on this planet. Sea level rise is accelerating in direct response to ocean warming. Carbon Brief confirmed that sea levels reached record highs in 2025, continuing what it described as a notable acceleration over the past 3 decades. Ocean warming contributes to sea level rise through 2 mechanisms. First, warmer water expands physically, a process called thermal expansion, which alone accounts for roughly half of observed sea level rise. Second, warmer oceans melt ice sheets and glaciers at their margins, adding water mass to the ocean system. The combination of these 2 effects is pushing sea levels upward at a rate that coastal planning, in cities from Miami to Mumbai to London to Shanghai, was not designed to accommodate. Berkeley Earth's annual temperature analysis, released in January 2026, projected that this year will likely rank as roughly the 4th warmest in the instrumental record going back to 1850. That number appears reassuring until you understand the context. The 4 warmest years in the entire 176-year instrumental record are 2023, 2024, 2025, and 2026. Every single one of them has occurred in the last 4 years. Not the last decade, the last 4 years. And with a growing probability of an El Niño developing by mid-year, the second half of 2026 could push temperatures higher than the La Niña-suppressed first half suggests. Carbon Brief explicitly flagged that an El Niño emerging in mid-2026 may lead to significantly warmer temperatures in 2027. The Paris Agreement established a target of limiting global warming to 1.5 degrees Celsius above pre-industrial levels. That threshold was crossed for the first time as an annual average in 2024. It was matched again in 2025. Environment and Climate Change Canada has forecast a global mean temperature of 1.44 degrees Celsius above pre-industrial levels for 2026, within a range of 1.35 to 1.53. The upper end of that range means another year at or above the Paris limit. And scientists from multiple institutions have confirmed that the 1.5 degree goal, as a long-term sustained average, rather than an individual year breach, is likely to be exceeded before the end of this decade. What is happening to the global ocean is not a side effect of climate change. It is its primary engine. The ocean is where the heat goes first, where it is stored longest, and where its consequences play out most severely for the longest period of time. Every degree of ocean warming that has already occurred is locked into the system. Every degree that is added in the years ahead extends the consequences further into the future. And the 9 consecutive years of record or near-record ocean heat content are not a temporary spike. They are a trajectory, one that every major scientific institution monitoring the planet's vital signs is now reading in the same direction. The ocean is not just warming, it is sending a signal. And the signal is one that the data says humanity can no longer afford to misread. There is one more layer to this story that scientists have been increasingly vocal about in recent months, and it concerns the pace of warming itself, not just the absolute level. For years, climate models projected that global temperatures would rise gradually and predictably as greenhouse gas concentrations increased. Built on assumptions about how efficiently the ocean would absorb heat and how stable cloud patterns would remain, these models were carefully validated against historical data. But the events of the last 4 years have prompted a serious and open discussion among climate scientists about whether something has shifted in the climate system that the models did not fully capture. 2023 produced a temperature anomaly so far above projections that researchers at multiple institutions described it as genuinely surprising. Scientists proposed several explanations. Reduced shipping traffic lowered sulfur aerosol pollution that had been partially masking warming. New fuel regulations, introduced in 2020, further reduced that aerosol shield. The Hunga Tonga volcanic eruption injected massive water vapor into the stratosphere, adding a fraction of a degree over subsequent years. None of these factors fully explains the magnitude of what happened. Carlo Buontempo, director of the Copernicus Climate Change Service, has stated that when the next El Niño materializes, it will likely drive another record annual temperature. His assessment, shared by several senior climate scientists, is that the baseline from which each new warming event starts is now so elevated that even a moderate El Niño produces temperature excursions that would have been record-breaking events by any historical standard. The world is not just warming. The pace at which it responds to natural warming cycles is intensifying as the background temperature rises. NPR's reporting on the 2025 climate data confirmed that all of the last 3 years have flirted close to the Paris Agreement's internationally agreed warming limit. Scientists from NOAA and multiple independent institutions confirmed that the Paris goal is likely to be breached as a sustained long-term average by the end of this decade. Not the end of the century, within the next 4 to 5 years. And the committed warming already stored in the ocean means that even achieving net zero emissions tomorrow would not prevent that breach. What this means for everyday life on every continent is a sustained escalation of every climate-sensitive risk communities already face. More intense hurricanes drawing energy from warmer seas, more powerful atmospheric rivers carrying moisture evaporated from hotter ocean surfaces, more prolonged marine heat waves bleaching reefs and collapsing fisheries, more rapid ice melt from glaciers and ice sheets surrounded by warmer waters, more accelerated sea level rise threatening coastal populations that have built their cities and economies on shorelines that are now moving inland. These are not predictions for a distant future. They are processes already underway, measurable in the data scientists publish every single year. The 9 consecutive years of record or near-record ocean heat content are not a streak of bad luck. They are the most fundamental signal the climate system has ever produced. The ocean is not returning to where it was. It is carrying the accumulated heat of decades forward into a future that looks increasingly unlike anything the historical record prepared us to manage. The planet is not waiting for political agreements to catch up. The ocean has already made its position clear.